Okay, we're going to do problems 3.4, 3.5, and 3.6, all on page 38. And so we'll go ahead and start here. So we're going to draw an FBD for each one of these. So 3.4, it says, consider a 10-kilogram box being pulled with a force of 20 newtons. So this is a 10-kilogram box. It's being pulled with a force of 20 newtons by a rope horizontal with the ground. The box is being pulled at constant velocity. So I'm going to have friction going back the other way, and it should be exactly the same length. I'm always going to have weight, Fg, going down, and I'm going to have a normal force going up, which in this case should actually be equal to the Fg. So there's my FBD, and it's being pulled at a constant velocity. So what is the coefficient of friction is what it's asking for. Okay. So Fg is the weight, and that's always going to be mass times gravity. So this would be 10 times 9.81 is gravity. So this is going to be 98.1 newtons is the force of gravity down here. Now I know that the normal force in this case actually has to be equal to that. So the normal force is also going to be 98.1 newtons. Okay, so it's a constant velocity. So that means this force and this force, any lefts and rights, they would have to be equal also. So I'm going to start my derivation with FF equals 20. In for friction, I can put my new equation, which we have. Friction is mu Fn. So in for friction, I could put mu Fn equals 20. And then mu would equal 20 divided by Fn. So mu would equal 20 divided by the normal force was 98.1. And if I do that on the calculator, 20 divided by 98.1 equals, I get 0.204 is the mu. So that's how you do it. Draw an FBD. And basically, you ask yourself a question every time. Is it constant velocity? If it is, you need to get all your right forces equaling all your left forces. That's how you start. You set all your left forces equaling all your right forces, and then you derive for whatever you need to solve for. If this was accelerating, then like I'm going to have here in a problem, I would start with Newton's second law, F net equals ma. So I either start with this if it's accelerating, or I start with having all the lefts equaling all the rights. And you do that every single time. All right, let's look at 3.5. 3.5. So consider a 10-kilogram box. Same thing. Got a 10-kilogram box. So I got force of gravity, which again would be mass times gravity. So it'd be 98.1 newtons. I have Fn going up. It's being pulled with a force of 40 newtons this time, 40 newtons. Okay. And with the ground coefficient of friction is a 0.10. It tells us that. What is the acceleration of the box? Okay, so it's accelerating. That's what it tells me. So I know the friction going back this way is not as long as this one because there needs to be some net force. So I just said in the last problem, if you have constant velocity, you have all your rights equaling all your lefts. But if you have acceleration, you always start with Newton's second law. F net equals ma. And the first thing you need to do is figure out what is F net. Well, F net would be any of the forces subtract out the other forces. So you want to figure out how much force is left over going this way. So this net force would be 40 minus the friction force. That should equal ma. This would be 40 minus what's friction force. If you remember, friction force is mu Fn. So it would be mu Fn equals ma. So that would be, I could do it this way. I could move the mu Fn over. I'm just to keep on this other side. Mu Fn would be over there, would be 40 minus ma. So mu, actually we're solving for mu. What are we solving for here again? We're solving for the acceleration. Okay. So actually, I didn't really want to do that part. Got to remember what we're solving for. I wanted to keep this on this side. So MA equals 40 minus mu, and mu is 0.1 times the normal force. And we actually know that the normal force is equal to this. This should also be 98.1 because it's not accelerating up in this direction. So I'd put a 98.1 in there. And then acceleration then will equal 40 minus 0.1 times 98.1 all over the mass, which was 10. Okay, so if I do that on the calculator, 40 minus 0.1 times 98.1 equals, divided by 10 equals, and I get a 3, acceleration equals 3.02 meters per second squared. Okay, so in this problem, I had an acceleration, so I had to start with Newton's second law. F net equals ma, and I just needed to solve for the a once I tried to remember what I was trying to solve for. Okay, so that's 3.5. All right, we're going fast, but you can pause the video if you need to. 3.6. All right, we have a 46 kilogram box. It's being pulled with a force of 260 newtons by a rope that makes an angle of 30 degrees to the ground. Okay, it's a harder problem. So I'm going to be pulling here 260 newtons, and the angle here is 30 degrees. Okay, we clearly have friction still this way. We have the weight going down. We have a normal force going up. This weight here would be mass times gravity. So it would be, if I figured out, it'd be 46 times 9.81. It's 451. 451.3 newtons is Fg. Okay. This force is not perpendicular or parallel. If you remember from our FBDs, we need to take this and resolve it into something going parallel and something going perpendicular. And so this side over here would be 260 times the sine of 30, because it's the opposite side of the angle. And this would be 260 times the cosine of 30. And I can figure them out. This is easy. This is 130, half of 260. And then also 260 times 30 cosine equals 225. So this one is 225 newtons. Okay. So what are we solving for here? We're solving for mu. We're trying to figure out what mu is again. Okay. And it's being pulled with constant velocity. So I need to know that because I need to know, am I going to do rights equal lefts, or am I going to start with Newton's second law? Constant velocity means I'm going to do rights equal lefts. So there's only one going right and there's one going left. So friction force is the left, and that should equal the right, which is 225. So that's how I start. That's it. That's how I start my derivation. Okay. So friction force is mu Fn equals 225. Okay. So mu equals 225 divided by Fn. So mu equals 225 divided by, okay, what is Fn? Here's Fn, and normally you might be tricked in this problem. You might think, oh, Fn, same as this. But in this problem, of course, what we talked about in the FBD, it is not. Remember, the ups need to equal the downs. So I have Fn going up. I also have 130 going up. That should equal the 451.3 going down. So how do I figure out Fn? Fn would be 451.3 minus 130. So it'd be 321.3 is my Fn. Okay? This is 321.3. Notice Fn is not the same as the weight. It's smaller because there's also an up force of 130. This and this equal 451.3. Ups have to equal downs. So I'm going to take 225 divided by 321.3 to get my mu, and that comes out to be 0.70 QED. That's how you do problem 3.6. So hopefully you understood all those force FBD problems, and we're then going to start on inclined plane problems next.